On this Ram 1500 DT with the 3.6 Pentastar, P0353 points to the ignition coil 3 primary circuit. In plain terms, the PCM may not be seeing the coil 3 signal current it expects. The MIL can illuminate, and depending on how the fault shows up, the engine may run rough, misfire, or have a starting complaint. The broad areas we're thinking about are the relay-fed coil supply, the coil 3 control circuit, the coil and plug area, connector quality, and the PCM driver. This monitor runs continuously with the ignition on, and the code sets when the PCM detects the ignition coil 3 signal circuit current is less than or equal to 0 amps for at least 1-2 seconds. Start with the basic system checks before getting into the code-specific path. First, use the scan tool to read DTCs in all ECUs and record the codes and environmental data. Save the scan report and the related recorded data. Then erase all DTCs, turn the ignition off for a minimum of 10-0 seconds, turn the ignition back on, and operate the vehicle under the conditions that set the code. Read DTCs again. If P0353 does not return, treat it as an intermittent condition. If it does return, continue with the diagnostic path. Next, look back at the recorded codes. If any ASD-related codes are present, check what they mean first and handle the applicable diagnostic path before continuing with this coil circuit test. If there are no ASD-related codes, move on to the coil supply circuit load test. Now load test the relay F343 output side feeding the coil supply. Disconnect the component harness connector so the 12-0-volt supply circuit is isolated. Connect the positive lead of the load test tool to the 12-0-volt supply circuit at the component connector and connect the negative lead to battery ground or a good chassis ground. Make sure the circuit is actually powered during the test. If it is relay-fed, the relay needs to be energized and on. A good circuit should light the load test bulb bright. A 3156 bulb is a useful example here. It has approximately 6.0 ohms of resistance when powered and draws approximately 2.0 amps. A high-impedance test light that draws less than 0.1 amps is not reliable for this load test. The tool should draw more than approximately 0.75 amps. And if you want to prove there is no hidden resistance, voltage drop across the 3156 bulb. As an example, 2.0 ohms of added circuit resistance can make the bulb voltage 25% less than battery voltage because the total circuit resistance becomes 8.0 ohms. If the bulb is bright, continue to the coil control circuit test. If it is not bright, repair the 12-0-volt circuit for an open or high resistance. If the fuse is open, check that circuit for a short to ground. Then verify the repair and confirm the code stays gone. With the supply side proven, check the coil 3 control circuit. Use a 12-volt test light connected to a 12-0-volt source and probe the coil 3K18 control circuit at the ignition coil harness connector. Crank the engine for 5.0 seconds while watching the light. Stay clear of the fan, belts, pulleys, and loose clothing while the engine is cranking or operating. If the test light is brightly blinking, the control circuit is being pulsed and the path moves to the spark plug inspection. If the light is on constantly, go after a short to ground on the control circuit. If the light stays off constantly, go after an open or high resistance in the control circuit. If the test light was brightly blinking, turn the ignition off and remove the spark plug or plugs as needed. Inspect for cracks, carbon tracking, foreign material, gap size out of specification, and a loose or broken electrode. If one of those conditions is present, replace the spark plug. If carbon tracking is found on the spark plug, inspect the ignition coil boot for damage and replace the boot if necessary. Then verify the repair and confirm the code stays gone. If none of those spark plug conditions are present, replace the ignition coil and spark plug. Then verify the repair and confirm the code stays gone. If the test light was on constantly, isolate the coil 3K18 control circuit and check for a short to ground. The ignition must be off when checking continuity to ground. Disconnect the ECU and every component harness connector that contains the circuit being tested. Use the vehicle wiring layout to follow the circuit path. Put the DVOM negative lead on a known good ground. Then probe the circuit at the component harness connector with the positive lead. There should be no continuity between ground and the circuit. If continuity is present, repair the circuit for a short to ground, using inline connectors where available to help isolate the short location. Then verify the repair and confirm the code stays gone. If there is no continuity, continue to the coil and PCM driver isolation step. If the test light was off constantly, check the coil 3K18 control circuit for an open or high resistance. The ignition must be off for this continuity check. Isolate the circuit by disconnecting the ECU and the component harness connector that contains the circuit. Before measuring the circuit, measure the resistance between the two DVOM leads. Then connect one DVOM lead to the circuit at the component harness connector and the other lead to the circuit at the GPEC adapter. Do not probe PCM harness connectors directly, because that can damage the PCM terminals and create a poor terminal-to-pin connection. If a PCM terminal needs to be accessed, use adapter, GPEC Diagnostic 10436, at the correct PCM harness connector. Also remember that the GPEC Diagnostic adapter can add up to 1.5 ohms of resistance to the circuit. If measured resistance is below 3.0 ohms, continue to the coil and PCM driver isolation step. If it is not below 3.0 ohms, repair the circuit for an open or high resistance. Then verify the repair and confirm the code stays gone. Before condemning the PCM, determine whether the ignition coil is causing the driver failure. An internally shorted or damaged secondary coil circuit may be the reason the PCM coil driver failed, so do not replace the PCM until the coil has been checked this way. Remove the ignition coil controlled by the driver that's set P0353 and install that coil in another coil location that did not have a fault set against it. Turn the ignition on. Erase DTCs, then start and run the engine for up to 1 minute. If the engine will not start, crank the engine 3 times for 10 seconds. Read DTCs with the scan tool. If a correlating fault sets for the new coil location, replace the ignition coil and replace and program the PCM, then verify the repair and confirm the code stays gone. If a correlating fault does not set for the new coil location, continue to connection checks. If the coil swap did not make the fault follow the coil, check the related PCM and component connections. Handle any applicable bulletins first. Disconnect all PCM harness connectors, any related inline harness connectors if equipped, and the related component connectors. Inspect connector installation, connector locks, corrosion, water intrusion, weather seals, bent terminals, overheating from a poor connection, terminals pushed back into the cavity, spread terminals and terminal tension. Repair any conditions found. Then reconnect the PCM connectors, inline connectors if equipped, and component connectors, making sure they are fully seated and the locks are fully engaged. Erase DTCs, test drive or operate the vehicle under the conditions that run and set the code, and read DTCs again. If P0353 returns, replace and program the PCM, then verify the repair and confirm the code stays gone. If it does not return, the wiring or poor connection problem has been repaired. Verify the repair and confirm the code stays gone. The key on P0353 is to prove the circuit before replacing parts. Confirm the code, check for ASD-related faults, load test the coil feed, read the control circuit behavior, and only then separate spark plug, coil, wiring, connector, and PCM driver faults. For more diagnostic training, visit stepdiagnostics.com.